So, look, today we need to talk about what just happened on July 16 because the frontier landscape of AI just experienced a massive earthquake. Moonshot AI, a Chinese lab, just quietly dropped Kimi K3, and it is completely rewriting the rules of the open weight model space. Imagine waking up and realizing the gap between the absolute best closed American AI models, like Anthropic's Claude Fable 5 or OpenAI's GPT 5.6 Soul, and open source Chinese models just collapsed. Actually, it didn't just collapse, it turned into a rounding error. We are talking about a 2.8 trillion parameter model. To put that in perspective, the previous Kimi K2 family hovered around 1 trillion parameters. They basically tripled the size, bumped the context window to a massive 1 million tokens, and gave it native vision and video understanding. But here is the most fascinating part of the launch, the pricing. For the last couple of years, Chinese open weight models have played a very specific game, right? The goal was always to be, you know, 80% as good as the American models for 10% of the price. Moonshot just threw that playbook out the window. Kimi K3 costs $3 per million input tokens and $15 per million output tokens. That is exactly Claude's Sonnet-Tier pricing, and it's basically 5 times more expensive than their own K2 family. But this is expected because, well, let's look at the actual math, since running a massive model like Kimi K3 is definitely not free. The hardware requirements are absolutely brutal. Even if you quantize a 2.8 trillion parameter model down to 4-bit, you are looking at roughly 1.4 terabytes of VRAM just to load the model. And that is before you even factor in the extra hundreds of gigabytes needed for the KV cache on a 1 million context window. So yeah, this model gonna cost more. So naturally, the question is, does the performance actually justify the price tag? Well, the launch numbers are frankly insane. On the front-end code arena, which is a blind human preference test for real design and interface work, K3 didn't just do well. It took the #1 spot outright. It scored 1,679 points, beating Claude Fable 5 and GPT 5.6 Soul. But the real flexes are the long horizon agent demos. Moonshot had K3 do a 48-hour autonomous run, where it literally designed a microchip. Using open source electronic design automation tools, the model mapped out a chip architecture, wrote the register transfer code, verified it, and closed timing at 100 megahertz. It basically built a chip designed to run a smaller version of its own architecture. In another demo, it built a GPU compiler from scratch, a compact Triton rival with its own intermediate representation that actually matches Triton on certain workloads. Now, before we get too hyped, we have to talk about the skepticism. Because, vendor demos are vendor demos, and they are notoriously cherry picked. Independent evaluators have started getting their hands on it, and the picture is a bit more nuanced. Artificial Analysis tested K3 and gave it an ELO score of 1,547 on their private long horizon knowledge work benchmark. That is a massive 732-point jump from Kimi K2.6, but it still puts K3 behind Claude Fable 5 and GPT 5.6 Soul overall. Moonshot's own technical blog actually concedes this, admitting that its overall user experience still trails those top two proprietary models. There is also a huge catch regarding the cost. Remember that $3 and $15 rate card? Well, right now, K3's thinking effort parameter is locked to maximum. It literally cannot stop thinking deeply. Simon Willison, A well-known developer ran his classic pelican riding a bicycle benchmark, a simple prompt to generate an SVG image. The prompt was 95 tokens, but K3 burned through over 13,000 reasoning tokens just to draw the pelican. The whole thing cost 25 cents for a single image. Because it generates massive reasoning traces for every single task, your actual cost per completed task might be much higher than you'd expect from the raw token price. Artificial analysis found that K3 produced more than twice the median number of output tokens compared to its peers. So how is Moonshot actually serving a 2.8 trillion parameter model with a 1 million token context window without their servers spontaneously combusting? This is where we have to talk about the technical architecture because it is brilliant. First, on the model side, they implemented something called Kimi Delta Attention, or KDA. Standard attention mechanisms scale quadratically, meaning they choke on memory when you push them to a million tokens. KDA is a hybrid linear attention mechanism that Moonshot claims speeds up decoding by up to 6.3 times over massive contexts. They paired this with attention residuals, which lets the network selectively retrieve representations across its depth rather than accumulating them layer by layer. This gave them about 25% higher training efficiency for under 2% additional compute cost. And remember, this is a mixture of experts model. Out of 896 total experts, K3 activates 16 per token using a framework called Stable Latent MOE. But the real secret sauce is their serving infrastructure. Moonshot published a paper detailing their system called MoonCake. It all revolves around the KV cache. So, what is the KV cache? As the model processes every token, it computes keys and values. So the KV cache contains information for system prompt, user prompt, previous assistant replies, and newly generated tokens. It improves inference speed significantly, as the model doesn't have to regenerate the same tokens again and again. But the problem is, the KV cache can become gigantic. Imagine 1 million token context for Kimi K3, and every token stores K and V, then multiply by 120 transformer layers, and now multiply by thousands of users. The memory requirement explodes in no time. The traditional solution is to store model weights and KV cache in the GPU for faster inference speed. MoonCake asks, why are we storing everything on our expensive GPUs? Their solution is to store the most recent KV cache in the RAM, then older KV cache stays in the SSD. Use all GPU memory for models only. So you must be asking, doesn't it get slower storing KV cache in literally SSDs? So why does MoonCake still do it? Imagine a GPU with 80 gigabytes of VRAM. Suppose model weights take 70 gigabytes. KV cache for one long conversation takes 8 gigabytes. You can only fit a few users before the GPU is full. Now imagine 100 users. Impossible. MoonCake's approach is, out of 80 gigabyte GPU RAM, 78 gigabyte is allocated for the model weights and 2 gigabyte for working space. The big KV caches live elsewhere. For example, in RAM, user A's KV cache, user B's KV cache, and user C's KV cache, while the older KV cache is in SSD, along with other archived KV caches. Now the GPU can keep serving requests instead of being clogged with inactive caches. Isn't copying from RAM slow? Yes. But compare two options. In option 1, you have to recompute. Suppose processing a 1 million token prompt takes 2 seconds. In option 2, suppose loading the cache from RAM takes 150 milliseconds. Even though RAM is slower than VRAM, 150 milliseconds is still much faster than spending 2 seconds recomputing the prompt. That's the key comparison. You're not comparing RAM versus GPU, you're comparing load from RAM or recompute millions of neural network operations. Loading often wins. It's like fetching an old book from the basement of the library is much faster than rewriting the entire book. Here, I must say that this actually works in an enterprise solution where Moonshot is serving thousands of customers. They use something like a conductor that routes the traffic and decides which KV cache should stay in RAM because it is used more often by thousands of customers who frequently have the same question, and which KV cache should be archived in SSDs because it is used less. This wouldn't work well for local users. Still, there is some research going on, like persistent KV cache. Imagine you're writing a book. Every morning you reopen the same conversation. Currently, you have to open the model, read 1,000 token prompt again, and wait 20 seconds. Instead, you can load yesterday's KV cache and resume instantly. That would be fantastic. Another interesting idea that can be used in local systems based on what MoonCake proposes is a hierarchical KV cache. Research suggests attention is not uniform. Models tend to focus on the most recent context the most, then comes a few important earlier tokens, and occasionally something far back. Most old tokens receive very little attention. This is why many researchers think hierarchical caching is promising. Okay, so the tech is brilliant, but who is actually using K3 and is it safe? This brings us to a massive divergence in how the US and China are handling AI risk. In the West, Anthropic was sounding the alarm about their models being too good at cybersecurity and biology. The US Commerce Department actually classified Claude Fable 5's underlying model as a controlled munition. So Anthropic had to lock it down. If you ask Fable 5 to do complex offensive cyber execution, it hits a hard-coded fallback system and aggressively downshifts your prompt to the older, safer Claude Opus 4.8. Moonshot, on the other hand, is walking a totally different path. On July 27, 2026, they are dropping the full 2.8 trillion parameter weights of K3 into the wild. Open weights, no cloud level classifiers. This creates what security analysts call the harness problem. K3 is incredibly good at terminal tasks. Because the weights are open, anyone can wrap K3 in a Python harness, hook it up to a live terminal, and just let it run autonomous execution loops without Anthropic looking over their shoulder to shut it down. And there are massive privacy considerations here too. Comet API did a security analysis and pointed out that Kimi falls under China's national intelligence law, which requires companies to assist state intelligence efforts. Moonshot's privacy policy essentially allows user prompts, files, and images to be used for model training. There's also a tool called Kimi Claw. These are always on browser agents that can observe and act on your digital activity. Hooking a Chinese hosted persistent agent into your browser infrastructure obviously introduces massive supply chain and credential theft risks for enterprise users. There is also some serious drama in the background. Back in February 2026, Anthropic actually accused Moonshot of spinning up thousands of fake accounts to scrape millions of conversations from Claude to use as training data. Moonshot isn't the only lab accused of distilling Western models, and it's technically still just an accusation. but it definitely hangs over all of these benchmark claims. Despite all of that, the enterprise adoption is happening, and it's purely pragmatic. In India, for example, massive IT firms are already running Chinese open models. Why? Because if you download the open weights of K3 on July 27th and host it entirely inside your own internal network, you solve the data sovereignty problem entirely. It doesn't ping servers in Beijing if it's running on your own metal. And with cached input pricing at 30 cents per million tokens, you can run massive autonomous web research agents for pennies. So, what's the verdict? If you are a developer right now, K3 is a fork in the road. If you are doing agentic web research, K3 is arguably the best in the world right now. It scored a record 91.2% on BrowseComp, meaning it is elite at crawling the web, cross-checking conflicting sources, and compiling data. But if you are just doing high volume, standard coding tickets, K3 is overkill and way too expensive. You are better off routing the hard 20% edge cases to K3 and keeping the bulk of your work on the older, cheaper Kimi K2.7 code model, which Moonshot is keeping online. And for zero margin of error enterprise tasks where a single hallucination destroys an hour of work, Claude Fable 5 is probably still the safest bet because of its deep compounding accuracy. Ultimately, K3 is proof that the moat closed AI labs thought they had is gone. We now have a 2.8 trillion parameter model that can design chips, compile its own code, and browse the web, and in a few days, anyone with enough server racks can download it for free. The open weight market just hit the frontier, and the pressure is completely on OpenAI and Anthropic to prove what their premium price tag is actually buying you anymore. That is all for today's breakdown. I will see you in the next one.